you have 5 minutes to prepare, but you can start whenever you are ready. Write down your name, please. So reporter, please start the presentation.
Hi everyone, I am the reporter from the team cell. I'm going to report the problem-free lato-lato. Now the overview. First, we'll explain the problem statement and the experiment setup, and also the method and the concept. For the concept, we use the 4 parts to explain it. The first one is how lato-lato starts, and the second one is how to convert the vertical force into a horizontal force. The second one is coefficient of restitution. And the last one is small angle simple pendulum current formula. About the problem statement, attachable to each end of string and connect the center of the string to a pivot. When the pivot oscillated along the vertical direction, the balls start to collide and oscillate with increasing amplitude. Investigate the phenomenon. And we are focusing about the key point, the increasing amplitude in the further experiments. About our experiment setup, first, we pattern paper with a scale, and the scale is 5 centimeters. And so that we can use tracker to locate, to record the position of the lato-lato. And also prepare some sticker on the table, and that's it to make sure the camera's displacement won't be moved in every time. And to make sure the camera and the wall is parallel, and also keep a distance, and the distance is 2 meters. Experiment setup. And here is some basic information of our equipment. First, the ball is, one ball is 70.77 grams, and the other one is 7.8 grams. And the string is, the length of string is 20 centimeters, and the radius is 1.5 centimeters. About the experiment method, we upload the video to the tracker and to analyze the locus of the lato-lato and other data. And in the end, we upload the data to the Excel to make the analysis. The concept 1, how lato-lato starts. We found that the initial speed is necessary to start lato-lato's movement. As you can see, without a gap between two balls, the oscillation never begins. Okay. However, with a gap between the two balls, the oscillation can start smoothly, just like a video shows. The second concept is that how to convert the vertical force into a horizontal force. We'll explain it in a two perspectives. The first one is explained from the perspective of force. First, the handle will do the tension force of the rope, and also the mass of the ball will give the force called weight. And this two kind of force will make the horizontal components. And the other perspective is that explain this phenomenon from the energy. Okay, the two balls have its own gravitational potential energy, and the handle pull out the lato-lato, and when the two balls hit together, and it got another force to the more high place, and And when the two balls get more higher, the potential energy is more higher too. And also the hand, when the handler pull out the lateral, the force the handle do and the force the bumping to make it will make the lateral more higher and the potential energy will more higher. And then the two balls fall down, the potential energy will turn to kinetic energy. And for sure, that's for 100% is trained to the kinetic energy. The process will lose some energy, maybe into like heat. Well, energy transfer between potential energy and kinetic energy. Okay, when the two balls collide with each other, two kind of energy will transfer. And about energy transfer, if this condition is elastic, you can see the formula of the elasticity. And if the two mass of ball is the same, just like this shows, if N1 equal to the N2, and also the V1 equal to the U2, and V2 equal to the U1. And the U1, U2 means the initial speed. And the V1 and V2 means the final speed, the final velocity. Okay, if U1 equal to U2, then in that condition, the V1 will equal to the U1. However, our lateral is in the case of the inelastic. So the U1 will equal to the U2. However, the final velocity will not strictly equal to the U1. Then there will have the coefficient of restitution between that two velocities. About the COR, coefficient of restitution, and we use the V to represent the COR. And the COR is about the separation velocity divided to relative velocity before collision. So the E will equal to the V2 subtract V1 and the U1 subtract V2. And as you can see in the photo, when the two balls hit together, and when it is a condition of the elastic, they will go back to the same head every time. About the concept, the small angle formula. And as you can see the photo there, the H means the initial height, and when it collides to the yellow ball, the orange ball will go back, but not go back to the initial head. And the H point means the final head. Okay, from the previous concept, we can know that the V1 will equal to the alpha V, and the V means the initial velocity, and the V1 means that the final speed. And the alpha here means that the COR, coefficient of restitution. And when the potential energy turns into the kinetic energy, there is a formula to show that. However, when you multiply alpha x squared, the formula will show like this. And the H point here equal to the alpha squared H. That means the first impact of the two balls. And H double point means that the alpha squared H point and the alpha squared H, and this square means the number of impacts. So this is the second impact. And this small t means all the systems, the time, and this capital T means the once period, the lateral. And with some calculated, we can know that the COR will equal to this. Now the concept, we use the simulation to show this concept. And as you can see, the E here means the COR is 0.9, and the F means the frequency is the 1.12 here. However, the lateral movement is not regularly because the handler's frequency not fit to the lateral frequency. Here's another simulation. However, we choose the frequency as the 2.24. That makes the previous double. So in this case, lateral will move regularly. And in this simulation, we push the E to the 1. That means this is an elastic. That is the elastic condition. About data analyzing, well, we use hand to do this experiment. However, the startle deviation is very small and very close to the zero. And also, we calculate the zero.
Time's up. So time for opponent to ask a question.
Okay, thanks for reporting. And for our first question, is the ball always hit at the same point when you do experiments?
Oh, we just can barely keep it that condition.
Okay, so, okay, I got it. Then go turn to page 8. It's okay. Okay, page 8. Yeah, here, what's the gap mean in here? The gap.
The gap means the tuble's resistance.
So mean like you have put the initial to carry down to that default.
Because in our experiment, we won't use hand to start this experiment. This is more easier to show this content, so we use hand to make gap.
Okay, I got it. And there's a reach now. Yeah. Here you measure energy. So may I ask where is the energy from?
Which end?
From perspective of energy, or what's the energy means in here?
Oh, energy means the handles made to the lateral energy, and also the gravitational potential energy,
Okay,
and also the kinetic energy.
I got it. So here's the next page. Yeah, here only consider the potential energy and the kinetic energy for lateral. That change. They didn't change transition.
Oh, this won't 100% transition. This will due to the state and time of the load, and some potential energy will transfer to the heat, so it won't 100% transition.
Okay, that is my question for further.
Okay, so time for preparation.
hello everyone. I'm a Poland from Nuri, and today the topic I'm going to post is problem 3, Lotto. The problem statement says that attach a ball to each end of the string and connect the center of the string to the pivot. When the pivot starts to oscillate along vertical direction, the balls start to collide and oscillate with increasing amplitude. Investigate the phenomenon. So the reporter's focus point is on increasing amplitude, and also investigate this phenomenon to explain the increasing amplitude reasons. And here's the summary of the report. The reporter used some lyrics to talk about why there's the increasing amplitude. And first is about the first analysis of the Lotto. The reporter has drawn some graphs to show in the Lotto have the weight affected and also the tension, and also when it's striking it will have the force. Also try the force analysis diagram to show how it works. And also the energy transfer, the reporter used lots of kinetic energy and potential energy to talk about how exactly the Lotto works. Also about simulation, I think it's a very good creative way to prove that with a different E or different mass of ball or different other parameters, that means we'll have some different trajectory of the Lotto. I think it's a very great way to prove his theory and assumption. Also, the setup in the report used in the video, we use a sticker to mark the pivot point so you can check it to have a make sure it's very stable, and also use a camera to put it at a special distance so it won't have a round distance. Also use a string and ball to connect up with the same weight of the ball to do experiment. And about parameters, you use a different mass of ball, and also the result shows that the energy transfer will cause an increasing amplitude between the Lotto and the pivot point. Here's the strength of the reporter. The reporter has used some graphs to show what the Lotto exactly is, and about using tracker to analyze the motion of the Lotto. I think that's a very great way to present how the Lotto plays in here. Also, there's a clear observation of the height changing in here. Also discuss the different energy transfers in here. I think that's also a very great observation of looking at the phenomenon of Lotto. And also have used a formula like a single pendulum formula to describe the Lotto situation. But there's some still my misunderstanding, so that's what I have to study later. And also use a simulation to compare the theory or change the parameters to see the difference assumption and its data. But there's some suggestions that the reporter there's lack of a qualitative comparison between the theory experiment about the simulation, what's the difference between experiment, and also there's lack of explanation about the experiment results, like maybe there's a critical value that will reach to a maximum point or something else. And also there's lack of planned experiment. We actually like to see the reporter to measure the single pendulum movement. Also there's too much word on course yet, and this is all my conclusion for reporter, so I'm inviting the reporter to have discussion. Okay, so can you first show me the video about you playing the Lotto? Yeah, at this page. So in here you just move the play Lotto at a space, right? Just like this page. But you consider that maybe the ball will collide like this, or just you think it's just in the same plane.
So we will only consider it as a predictive model, and we do our best to transfer it along.
I have a suggestion that maybe you can use. So this is your head. This is like your head, and this is a ball. I think maybe you can put a board on the back of the Lotto. So like this, but of course you need to consider friction between, but you can limit the Lotto on the surface. So how about your opinion about putting the board?
The improvement is always all the time. This video is only a mentioned video, so the real experiment will counter it more accurate.
You mean so you have control it?
Yeah.
How do you control it?
Part is I think the way to solve this problem is very useful.
Okay, thank you. That is okay. Thank you. Okay, so can you turn to page 12? Sorry, 11. Yeah, in this page you said, so what's the red mark mean on this?
The one general component in the direction.
So like the force of the horizontal direction. But how about the motion of the Lotto? Because in your video it says that in this slide, the lotto will move like this, like a circle. So, if you draw a force direction like this, I think maybe the lotto will keep moving like this. So, can you tell me more about what the red mark means?
Everything. The direction will be a circle.
So maybe your lens is just at the moment, maybe that the lowest point, the direction they're going to is the lowest point.
Yeah, that's going to be one
Okay, I got it. Yeah. And so let's turn to page about the talking about E. Next page. Okay. So what's the U means in here?
Oh, and E means the coefficient of restitution, and the U means the initial velocity.
So you want to, I think, so you may want to figure out the collision density, the velocity before the collision and after collision relationship.
Yes, the relationship is that when it after collide, the initial speed will modify COR will be the final speed.
Oh, so how about how big the E is in here in your experiments?
Oh, do the capture in the sorry, we change the distance.
So your E is 0.9, and do you think maybe this is too big or too enough? So, sorry, may I ask what's the material of your ball that you're using an experiment? Good. So, how about 0.9? Can you try to tell why do you think 0.9 is too big? Because 0.9 is very close to 1, but you use the material of
Consider.
Okay. Right. So I think maybe you can put like a velocity before, the after, and the before, so you can have more proof to prove that the 0.91. Yeah. Okay. So then first take to page 17. Yeah. So in here you try to use a single pendulum ruler to describe the lotto. Yeah, but the single pendulum is just when you put a ball in and you just let it fall down. But in lotto, your hand just keep moving. So we have some difference between these two ruler or some concept.
So you think it's not strongly related to that one?
Maybe there's a related, but yeah. Just I want to ask, how about the hands that you your hand keep shaking up and down? And how about the effect of your hands? Yeah.
How my hand
Will affect the both motion. Yeah.
Yeah, for sure. While the friction of hand, our hand will beat the loud button will move more fast.
So you think so? Even just very big, will keep faster,
No, it has its own limit.
like a critical value in here.
Sometimes you get
Yeah, let's calculate it.
the flood is well.
Yeah, and it becomes slower.
Yeah, this will be a more stable in the end.
What's the stable meaning here? Just keep with the same attitude.
Yeah, as you can see, the line of the large of this chart is almost the same.
Okay, so and do you think there's other parameters like the length or the pivot, the attitude of the pivot will affect the motion? Because you okay, just to use the single pendulum equation, and you have the length in L in here. So do you think the length of the rope maybe will affect the stable of the lotto?
Yeah, but I think this will get a more bigger related to the period of number. And
Okay, so do you think it's a positive relationship or a negative relationship? Like maybe with a longer strength of the string, maybe you will have some bigger increase in amplitude, I guess. So can you tell me about your opinion? Why do you think you will have a positive relationship? A positive.
That's up to the way you use the equipment. So is that the negative or positive?
I mean, the positive in here, I mean, maybe with the longer string, the length in here, maybe you'll have a bigger increase in amplitude. So you think you will have a bigger amplitude with the strength, become longer. Okay, tell more about your opinion. Why it will become longer when the strength becomes longer too?
And it can be explained by the little single formula.
Yeah.
The length is more bigger and the T will be.
Yeah, but this formula is used to the simple pendulum period, which means that you fix this point in here. But in lot however, your head is keep moving around. Or do you think there's a difference between these two systems?
Actually, we did a theoretical and real calculate about the small angle formula and the result. And the result is in theory is 0.89, but in practical is 0.06. So I think that is closer enough. So I think this formula is related to this number. Yeah.
How about page 26? About you're talking about the theory stuff. So 24. About you use the 23. Yeah, we here in the simulation, so the F is mean the pivot frequency about your simulation. The F 2.241 is the pivot frequency, this point frequency for the other things.
So that's about the 10. I know that's 10.
And do you think, oh, I got it. But in here, how about the 0 degree, about last one? What's the degree means? In this one, of this one.
Oh, I didn't consider it.
Okay, so can you judge, how about your opinion about, yeah. Just which angle you think is the left part? Yeah.
It might be the
Gap?
the white pole angle.
Okay, got it. So for first, the most important part is about you use the energy transfer in your report. But still consider that your hands keep moving or there's also giving energy to your lateral.
Oh, yeah. So that's stop moving.
Yeah, but in your transform, you only use the kinetic energy and the potential energy of the two both to describe the different changing position. Yeah, so how do you consider the hands energy? Yes, because you keep up and down, so maybe there's like energy that you put into the both rounds. Yeah, so yeah.
Okay, time is up. So time to summarize.
Okay, after having a discussion with the opponent, I say about how the simulation works and about some definition about the simulation parameters. And so I also asked about the most important one is about the frequency of the pivot point. And reports said that the pivot point frequency can get transformed by a single pendulum motion. But I think because you need in a lot of your hands keep shaking, I think there's also a fact that motion of the lateral. So I think maybe the report, of course, is based on the equation of a simple pendulum. But I think you could do some fix that added consider your hands affect your bone. And also, actually about in a real life experiment, the report said that sometimes they will not collide in the same point. So I suggested you can use the port to block the motion of the lateral so you keep at the same plane. But of course, they do consider friction. So I reports will do it in the future, and this is my summary of my discussion with the reporter.
Okay, so time for reviewer to ask questions.
Okay, so I have several questions to the reporter and the opponent. So first, for reporter, can you turn to page 5? The experiment setup. Also, can you explain what is the reason of you to use the paper to measure the ball's position?
Well, not to measure the ball's position, it's to locate the placement of camera.
I'm not mean that. I mean the paper. Let's go. Okay. So for the
We use tracker.
okay. Then for page 6, you mentioned that the ball of each ball have a different mass. So what did you think of the ball will collide not in the same position every time?
Yeah,
We need
it will collide at the same position.
Okay. What do the opponent do?
If you use a hand, you do it. I think sometimes won't collide in the same position.
Okay. Then next question, please turn to page 72. So how do you do this motion of the lateral? You use the theory or the experiment data?
It's a simulation.
So if you use theory, then is your theory have the strong relationship with your experience?
Yeah, because the mass or the length of string is the same in the real experience. So actually it's related.
But in your theory, the ball will collide at the same position, but you say that the ball will not collide in the same position every time. So is there any parameter that affect the experiment so that it doesn't have strong relationship to theory?
I think because we are best to make the two balls collide at the same point. I think it has some related with our experience.
Okay, how about the opponent?
I think this simulation, I think it's not based on the simple planar motion. I think it's based on arbitrary when the hand is even.
Okay. So next question is, can you explain why the movement is like this? You can go up and down into the stable accuracy. Okay, thank you.
Okay, so time to prepare.
I'm a reviewer from Team Galactic and I'm going to talk about the problem-free lato-lato. Here's the problem statement. Attach a ball to each end of the string and connect the center of the string to a pivot. When the pivot oscillates along a vertical direction, the ball starts to collide and oscillate with increasing amplitude. Investigate the phenomenon. And we feel the key points of this experiment is the pivot and the frequency of the ball. So the overview of the report. First, the theory part. The reporter focused on the increasing amplitude and applied force analysis. Analyze the energy transfer of lato-lato and apply the coefficient of restitution. Discuss the small angle pendulum period formula. And for the experiment part, they use tracker to analyze the motion. Use hand to do the experiment and do simulation, but no real experiment shown. For the conclusion, there is no conclusion. And the remarks to the reporter. For the advantages, the theory is easy to understand, and they do simulations to show the theory. But for the suggestion part, there is no real experiment shown, and the time management is not good. And the mass of two balls isn't very close. And they need to try to combine all the theory and need to be more familiar with the report. And the remarks to the opponent. The advantages. Give reporters suggestions during the discussion, and they point out the mistake of reporter. They use various examples to express the opinion. And for the suggestion part, they need to express the question more clearly and do more discussions with the reporter. And they can skip the topic where reporters can find. Okay, so let's talk about the discussion part. First is the reporter and the opponent discussion. So the opponent asks, did you only consider the potential energy and kinetic energy? The reporter answered yes, and it will decrease with alpha. It's a constant. And the reviewer answer is actually the input energy by oscillate the pivots with hand. The pivot will go up and down and will put energy in the system. The opponent asks, because of unstable hands, will lato-lato keep in the same position? The reporter responds that yes, we try our best to control this. But the reviewer answer is, it is impossible to keep the ball in the same position with hands, especially in a 2D model. So maybe reporter can make machine to avoid this problem or try to analyze this issue. And the opponent asks, the force and analysis in the pendulum case is not suitable for lato-lato. The reporter answered that we didn't mention this clearly. And for the reviewer answers, the balls must move much in the process, and the reporter shouldn't consider it as a small angle pendulum model. The opponent asks, how will the shaking frequency of the pivot affect the results? The reporter applied, the bigger the frequency, the bigger the velocity of the ball. The reviewer answer is, if the frequency is small, the reporter is correct. Okay, so I'm the reviewer and I ask, will the position be the same always? Will the position be the same when colliding every time? The reporter replies no, and the opponent agrees. So, in my opinion, I agree with the reporter and the opponent, but the reporter should explain about it. Okay, that's all. Thank you.
Okay, so it's time for the looping remark.
About the concluding remark. Okay, first, using hand to do the experiment may not be a good way, but the SD meter's standard dimension is so low that it's 0.004. It's very closer to the 0. So I think that didn't affect much, and even the machine can do it 100% accurate. In our opinion, lato-lato is a 2D motion. Try our best to make sure the lato-lato is parallel to the ball in eyes. Maybe we can add a second camera to the side of our experiment to make it more accurate. The third part is about the small angle formula compared to reality and theory. The difference is just 0.03. So we think it can use that formula in this case. In the end, yes, I actually said that won't be the same place each time when the two balls collide. But however, I think that could be no and wrong effect in all systems so much. That's all.
Okay, so time for the question from the jury. So any questions from the jury? So I have one question about I think the reporter you have mentioned about that you control the frequency and also you control the amplitude. So how about the frequency will influence a lot to the real analog motion. So how do you think, what is the best frequency in this case?
The best frequency.
Or is the frequency the most important key point for this analog motion?
You mean the hand frequency?
The motion frequency. Yes.
Motion. I think the most important factor is experience about the length of the string.
Is the length of the string. Okay. So how about it?
I think there's the three important. It's about the frequency and our pivot point and your amplitude, and about the length of your string. I think you need to find the best point between these three and these three different things to find the best points.
Okay, so how is it good?
I think it's the hand frequency and the distance of the top part and the amplitude. And then
So any other questions? Okay, so no
So-
question.
So-
Okay,
so-
yes, please.
So to discuss Lato, so this statement seems to me that the balls start to collide and oscillate with increasing amplitude. So for increasing amplitude, so that's how large of the amplitude do you think you should increase for this experiment or for the simulation or for their theoretical consideration? So do you have any idea? Or
For
suggestion?
me, when you start to collide from higher, and the simulation should either collide up or down and keep changing. This is increasing amplitude.
for Lato, it's about the ball collide and in the down part, and ultimately you will collide on the up part when the frequency is higher. So I think the frequency is determined by the ball movement will be stable.
And I think in the simulation or in the real experiment, the 90 degree is the increasing amplitude.
Okay, so any other questions? Okay, no, so we are ready for the score. So the score for the reporter. Four, 5, 6, 4. So the score for the opponent. Seven, 6, 6, 7, 7. So the score for the reviewer. 7, 7, 6. I cannot see, sorry. 6 and 6. So we conclude this session. Do any jury want to give some comment or suggestion. Okay, it's now we close this session.